Oh, our topic today is factors. Factors. Okay. So given 35 divided by 7 is equal to 5, right? And also 35 divided by 5 is equal to 7. We can say that 5 and 7 are factors of 35. So what is a factor? A factor is a whole number. A factor is a whole number that exactly divides into another number without leaving a remainder. Therefore 5 and 7 are factors of 35. Since if you divide 5 into 35, the answer is 7 and there is no remainder. And if you divide 7 into 35, the answer is 5 and there is no remainder. So the set of numbers that are factors of 35. Factors of 35. What are the factors of 35? Is equal to 1 is a factor of 35. 5 is a factor of 35. 7 is a factor of 35. And 35 is also a factor of 35. So we can write the 35 as a product of its factors. Like this. 35 is equal to 5 times 7, right? And 35 is also equal to 1 times 35. So let's work out another example. Find the factors of 12. The factors of 12 are, first, 1. Since if you divide 1 into 12, your answer is 12. 2 is also a factor of 35. 2 into 12, your answer is 6. There's no remainder. 3 is also a factor of 12. 3 into 12, your answer is 4. There is no remainder. 4 is also a factor of 12. 4 into 12, the answer is 3. There is no remainder. 6 is also a factor of 12. 6 into 12, the answer is 2. There is no remainder. 7 is not a factor of 12. Since 7 into 12, your answer is what? It's 1, remainder 5. There is a remainder. Up to 11, there are no factors of 12. But 12 is also a factor of 12. Your answer is 1, and there is no remainder. So I want you to carry out the following example. Find the factors of 18. May you please pause the video and work out the example, then later check out the solution that I'm going to provide. Okay, our solution. Find the factors of 18. Factors of 18. 1, obvious, 1 is a factor, right? Yes. 2 is 2 a factor? Yes, 2 is a factor of 8. Of 18, 2 into 18, it's 9. Is 3 a factor? Yes, 3 into 18, it's what? It's 6. Is 4 a factor? 4 into 18, it is 4 remainder 2. No, it's not a factor. Is 5 a factor? 5 into 18, it's what? 3 remainder 3. No. 6, yes, 6 is a factor. 6 into 18, it is 3. 7, is 7 a factor? No, 7 is not a factor. 7 into 18, it is 2 remainder 4. Is 8 a factor? Nope. 8 into 18, it's 2 remainder 2. Is 9 a factor? Yes, 9 is a factor. It's 2 remainder 1. 10 up to 17, they are not factors because they all leave remainders. And then 18 is also a factor. These are the factors of 18. It is easy, right? I know you nailed it. So this is how you now let us solve a different example. Which members of the set 2, 3, 4, 5, 6, 7, 8, and 9 are factors of 27 and 36? We'll solve A together, then you solve B on your own. Okay, which members of the set, of this set, are factors of 27? Factors of 27 from the set. Is 2 a factor? No, 2 into 27, it leaves the remainder, right? Is 3 a factor? 3 into 27, it's 9. Yes, it is a factor. Is 4 a factor? Nope, 4 is not a factor. It leaves the remainder 1. Is 5 a factor? 5 into 20. Oh, yes, 3 is a factor. 3 into 27 is 9, so 3 is a factor. Is 4 a factor? 4 into 27, it leaves remainders, so it's not a factor. Is 5 a factor? No, 5 into 27 is 5 remainder. No. Yes, it's 5 remainder 3. It's not a factor. 5 remainder 2, sorry. It's not a factor. Is 6 a factor? No, 6 is not a factor. Since it leaves a remainder, it's 4 remainder 3. Is 6 a factor? No, we said 6 is not. Is 7 a factor? No, 7 is not a factor. Is 8 a factor? No. 9, yes, 9 is 3. So this is the set of factors of 27, right? So easy. Now may you please pause and work out the part B, then we will continue after. The solution for your example. Solution for B, factors of 36. Is 2 a factor? Yes, 2 into 36, it's 18, right? Is 3 a factor? Yes, 3 is 12. Is 4 a factor? Yes, 4 into 36, it's 9. Is 5 a factor? No, 5 leaves a remainder. 6, yes, 6 into 36, it's 6. 7, no, 7 leaves a remainder. 8 leaves a remainder, but 9 is also a factor. So these are the factors of 36. Next up we are doing is prime numbers. What is a prime number? Prime numbers. A prime number is a number. It is a number with only 2 factors. With only two factors. That is itself and 1. It has 2 factors, that is itself and 1. Therefore 1 is not a prime number. 1 is not a prime number. Why? Because 1 has 1 factor and a prime number should have 2 factors. So what are the prime numbers? Examples of prime numbers. There is 2, yes, 2 factors, only 1 and 2. There is 3, there is 5, there is 7, there is 11. Right, these are some examples of prime numbers. 1 is not a prime number. So I want you to write down the set of prime numbers. Set of prime numbers from 1 to 30. May you please pause and work it out, then I'll give you a solution thereafter. Solution: prime numbers from 1 to 30. Prime numbers from 1 to 30. This is equal to there is 2, there is 3, there is 5, there is 7, there is 11, there is 13, there is 17, there is 19, there is 23, and 29. These are the prime numbers from 1 to 30. Okay, then after this we can now introduce prime factors. You now know what a factor is and a prime number is. So prime factors are factors that are prime. The factor being a number that divides into another number without leaving a remainder. And a prime number, it's a number with only 2 factors, that is 1 and itself. So what is a prime factor? A prime factor of a number, what is it? Prime factors. Prime factors, these are numbers that are factors of a number which are prime. So prime factors are factors of a number that are prime. So if a number is a factor of a number and it is also prime, then it is a prime factor. Therefore, it is possible to write every non-prime number as a product of its prime factors. Example, given a number like 12, e.g. given 12, and we saw that the factors of 12, the set of factors, we said there is 2, there is 3, there is 1, there is 2, there is 3, there is 4, there is 6, and there is 12, right? These are factors of 12 according to what we did earlier on. And we also mentioned that prime numbers are the numbers with only 2 factors, that is 1 and itself. So the prime factors of 12, are 1 is not prime, so it's not a prime factor of 12. 2 is a prime factor of 12. 3 is a prime factor of 12. 4 is not, 6 is not, and 12 is not. So this is the set of prime factors of 12. Formula that we can use to find the prime factors of numbers. Given, for example, a number like 24, e.g. find the prime factors of 24. Find prime factors of 24. We'll first start with the lowest prime number and find out if that number will divide into 24. And if it divides into 24, then we divide it into 24. And then we try again until it will not divide into 24. Then we move on to the next prime number. So given 24, how do we look for the prime factors of 24? We write it like this. What is the first prime number? 2, right? 2 into 24. What is 2 into 24? It's 12. Then next we try again. 2 into 12, it is 6. And then we try again. 2 into 6, it is 3. Then we try again. 3 into 3, it is 1. So the prime factors of 24 is 2 and 3, and we can write down as a product of its prime factors. 24 as a product of its prime factors. It is 24 is equal to 2 times 2 times 2 times 3, right? This is 24 as a product of its prime factors. So if you check with your calculator, you will realize that 24 is equal to 2 times 2 times 2 times 3. And we can write it in indices. This is 2 to the power of what? There are 3 2's. Like this, times 3. The next example, express 220, e.g. 220a as a product of its prime factors B. Write down the set of prime factors of 220. I will start with A. We said, how do we look for the prime factors? How do we find the prime factors? We use this formula. 220. We start with the first prime factors. It's 2 a factor of 220. 2 into 220, it is 110. And then next 2 into 110, this is 55. And then next 2 into 55, it leaves the remainder, right? 3 into 55, it also leaves a remainder, so it is prime factor. Then next 5, is 5 a prime factor? 5, yes, it is a prime factor. Then next 7, is 7 a prime factor? No. 11 is a prime number, so it is 11, like this. So 220 as a product of its prime factors, it is 220 is equal to 2 times 2 times 5 times 11. This is 220 as a product of its prime factors. Then in index form, this is 2 to the power of, there are 2 2's, 2 times 5 to the power of, there is 1 5. Then there's 111. This is in index form. And so part A is finished, right? Then we go to part B. Write down the set of prime factors of 220. Prime factors of 220 this is the prime numbers that are factors of 220. There is 2, there is 5, and there is 11. When you are writing down the set, you do not have to repeat a prime number, you only write it once. I'll give you this example and I want you to work it out. Express 1512 as a product of its prime factors. This is part A. Then part B. Write down the set of the set of prime factors of that number of 1512. May you please pause the video and work it out. Then after that, I hope you have carried out the example. Now I'll provide you with the solution. The solution for part A. What was the question? Express 1512 as a product of its prime factors. What do? We divide 1512. 2 into 1512. This is 2 into 15, 7, remainder 1. 2 into 11, 5, remainder 1. Then 2 into 12, 6. Then next we try again 2 into 756, 2 into 7, 3, remainder 1, into 15, 7, and remainder 1, and into 6, 16, 8. Then we try again 2 into 3, 1, remainder 1, 2 into 17, 8, remainder 1, 2 into 18, 9. Then 2 will leave a remainder 3. 3 into 18, this is 6. 3 into 9, 3. Then next we'll try again 3 into 63, 3 into 6, 2. 3 into 3, it's 1. Then we'll try again 3 into 21, it is 7. Then for 7 is a prime number, so it is just 7, then 1. So writing down 1512 as a product of its prime factors, it is 1512 is equal to 2 times 2 times 2, these 2's, times this 3, times this 3, times this 3, times this 7, like this. And then in index form, this 2 to the power of 1, 2, 3 to the power of 3 times 3 to the power of 1, 2, 3 to the power of 3 times 7. There's only 1 7. So this is how you write 1512 as a product of its prime factors. Then for B, write down the set of prime factors. The set of prime factors. Set of prime factors. Prime factors of 1512. This is equal to 2, 3, and 7. The set is only the numbers, the prime factors of 1512, the numbers that are prime, that can enter into 1512 without leaving a remainder. Thank you for watching this video.